Uh, the first two sections got you thinking about exponential functions, what they look like, and then the second section is logarithmic functions. Turns out that they are inverses of each other. We looked at that, saw pictures of them, played around with logarithms, converting them from exponent form to log form and vice versa. Today, we're going to take a look at some rules for logarithms. Gosh, I'm thinking of my algebra class, baby algebra. They had rules for exponents. So sometimes they added exponents, base is the same, multiply them, you add the exponents, base is the same, you divide, you subtract exponents. Then you got a parentheses with a power out here, you multiply exponents. So they had rules, so did you when you took beginning algebra. Here in maybe what we call advanced, you might call it pre-calculus, but advanced, super advanced algebra. And this section is review. This whole chapter is review, actually, from your intermediate algebra course prior to this. But there's rules. And so we're going to take a look at the rules, how they work, why they work. So it's a process. You're just learning processes. And then the last part of this section, probably all but one of you, it's calculator based. Probably all but one of you most of you won't need it. It's called change of base formula, change of base. And I'll address that when we get there. But right now, we've got, well, the book says 4 of them. I really only cover these 3. So those are the 3 that I'll cover. The root is actually a version of the power. The root is really the version of the power. All of you would know that this part right here, just what I am circling, can be rewritten as x to the 1 over p power. The pth root, or like the square root. Square root is a 1/2 power. Now, who learned that? Let's see. My beginning algebra class. Again, we just went over it just briefly in their course. So you first learned it there, and then I think you might have applied it in a 155 type class or intermediate algebra, the class before this. So this is the third time that you would maybe recognize that that is the same as 1 over p. So if this is the case, instead of that being the power that looks like it slides down in front, see what this, I'll work backwards. This power rule says that you could take the power on, and this is all inside the argument. The power on the base gets to slide down in front as multiplication, and you get the same result. That's what they're saying. So I could do the same thing here if I had this as log base b of that, then that would lead me to say it's 1 over p times log base b of x. Now that, what I just wrote, is the same as that. They are the same. You just put a 1 underneath this and multiply straight across, you get this right here. So that's why I don't focus on the root, because it's the same rule as the power rule. Now, if I look at any of these for the power rule, which I'll highlight here. So if I look at any of these that might look like the power rule, it would look like number 3. Number 3 is the power rule. So if I rewrote this, that's what they want you to write. Write it as an equivalent expression. So the x is the power. See, it's like the x here is the base. So that's like acting like c right here. The p for the power is the x. So that comes down in front. And then you have log base 3 of c. That's the rewritten version of it. By the way, I even showed you why it's true with some examples over here. I can rewrite 64s to the 6th power. I supposedly can take the 6 and bring it down in front. Supposedly the answer is just 6 when I'm done. I can check that with my calculator, see if that's true. I'll check this one first, and then I'll check that one second. Make sure they're both equal to 6. In my TI-84, sorry, 83 users, you don't have this. Is there anybody here to speak up if anybody here has an 83? Anybody today have an 83 calculator?
I do.
Okay, so you're sort of stuck for right now. You can't do a log base yet until we get to the last part of this section, which then I'll show you. It's pretty easy. That's called the change of base. So you'll be able to do it in your calculator. You just won't have this fancy feature that looks like this. So 84s, you should have this somewhere. What did I do? I went math here, the math button right here. And then I scroll down and I'm looking for log base. There it is right there, log base. So 84 users should have that. Hit enter. And if you have the upgraded operating system, you'll have little dialog boxes where I can put any base I want in there. Now, 84 users, how many of you don't have that? Because you might not have the upgraded operating system. How many of you do not have that? Speak up now or forever hold your peace. Okay, so it's whoever said, I don't, I'm not sure, it doesn't matter. Hang in there. You'll see how you can make log base, what I'm trying to do, 2 of 64 work for your calculator. See, it's 6. That's what I was trying to show everybody at 6. Then if I do this one, 6, and then you do log base 2 again, math, scroll, there it is. Oop. And put the 2 in there and go over here and let's see, I want to put a 2 again. Yep, 6. So they're both 6. Okay, excuse me one second. Somebody may have come in late, so I gotta see if that's true. Oh yeah, there's 4 people waiting. Selena, did I ask you or did you help out by doing the co-host before?
No, but I can do it.
Okay, so I'm going to go here and say thank you very much. You'll see it somewhere saying that you're a co-host. Then if you click on participants down to your bottom screen, it'll open up and you'll see all of us. And then at the top, you'll see participants parentheses 24. It'll turn out if somebody's in the wait room, it'll appear right below participants and it'll say admit in a blue button, just admit them. So thank you very much for keeping an eye on that. I just don't see it. I see a little red dot that someone just came in. That's all I see. I don't see the names. And I can't let them in unless I get out of my screen. Okay, enough of that. Go back to what I was doing. So though 4 of you that I just let in late, what we're doing is section 3.3. 4 of you just came in. Any of you have a TI-83? The 4 that just got in just a minute ago, 60 seconds ago. Anybody have a TI-83? Okay, so what I did, just to go backwards, again, hit the clear. I want to be, let's say I want to put in a log base 2. Everybody's got a log base 10 button, which is right there. That's a log base 10. And everybody's got a log base E, which is an LN. But you don't have a log base 2 button. So you have to go find the log. And if I just hit the math button and scroll down, and then you'll see log base right there, log base. And that's what you want to find. 84 users should have that. If you've got the upgraded operating system, you will have it. Hit enter, and then you can put in any base you want, like 2. And then 64, I want to put in a 64. And that produces a number, which is number 6, which is what I was trying to prove 5 minutes ago. So these rules that we were going over, and those of you who just came in, I'm only doing the top 3. I'm not going to demonstrate. I don't need to demonstrate the root one. So I'm doing these 3. And I just did the highlighted power one, like that one here. That's all you're doing is just rewriting it. Like this one here. I'm reading, excuse me, rewriting that. It's a product inside the argument. It's like the product rule right here. If it's a product inside the argument, then you write it as a sum of those pieces. Sometimes what we do is we talk about that as expanding, taking that and expanding. You know, I'll show you in your textbook, the instructions in your textbook. Let's see. You guys are in chapter 3. What am I trying to? Oh, instructions. Yeah.
Selena, you're the teacher now.
Yeah, I don't know what to do.
Did you just leave?
Yeah, class is dismissed. Bye, everybody.
No. You got to
Oh,
teach
he's
us
back.
about logs.
He's back, but Selena's still the teacher. Jeff, you're muted.
I had to press a button on my, well, I pressed accidentally. My computer went off. So yes, I'm back. Sorry. Let's see if I can. I don't have a big enough desk, so I think the book hit something here. Anyway, I was trying to show you. You're going to see. Oh, there it is. Expand. So you're supposed to expand. What? Like this one here. So you just put the 3 down in front. I don't know if you can see the light blue, but put the 3 down in front. So expand that, rewrite it, rewrite it, things like that. So that's what I'm trying to show you with these few examples is using the rules. This one right here would end up being log base C of R plus log base C of S plus log base C of T, it looks like. So whenever there's a product in the argument, then you make it into a sum. Whenever there's a quotient, here's the rule right here. Whenever there's a quotient, you make it into a difference. The denominator is always the second part. So numerator first, and then subtract denominator. So this one here would be log base 3, numerator first, 23, minus log base 3 of 9. And then the author says, which I'd like you to do too, if you can simplify, like this one can be simplified. See, 3 and 9 are very special. 9 is a power of 3. 23 is not any power of 3. This is the same as 3 squared. If you took a calculator and did this, you get weird decimal. If you took a calculator and did this, you would get 2. This piece would be 2. This one here, you have to leave alone. So this would be the answer in the back of the book. All right, this one has a combination of a couple things. You've got a product, so the numerator is going to be separated out as a sum, and the denominator, you're subtracting that at the end. So if I did this in two pieces, maybe if I did the quotient first, I would do log base b. Here's your numerator piece, minus, and then you separate this out. I'm going to run out of room. And then you minus this piece. You write this piece over again. So this is a product, so it becomes a sum. This was a quotient to begin with, so the denominator is being subtracted from the numerator. The rest of it is just doing similar things. Sometimes, and I have some examples, sometimes the book says rewrite, you got a bunch of logarithms with adding and subtracting, maybe something in the front of it. Rewrite it so it's a single logarithm. This is called a single logarithm right there. That's just one logarithm. So take this and go backwards. Can you take this right here and then, so you go one way and then you go the other way. Yeah, do this one. So I'm going to subtract that. I say be careful in this one because there is a sum down here, but this whole thing has to be subtracted from the numerator. I'll show you. Some of you are just going to do it. Hey, I'll do it all at the same time. Some of you just want to, I understand why you want to do this, because it's like, why couldn't I, like this one here, why couldn't I go from here to the bottom? You could, as long as you didn't make a mistake, but yeah, you could. You went, these two are adding, there it is, and that one is a subtracting. Hey, I'm done. What's the big deal? Well, the big deal comes like with this one, so if you're not careful. So here's the top, and then you say, I'm going to subtract, and then you go log base b of y, and then you go, hey, and then that's a product, so I'll make that into a sum. What's the big deal, Jeff? Well, the big deal is that's wrong, because the subtraction has to be to both of them, and you didn't make it that way. That's not right. This is right. That's correct. Oh, okay, the step before. Then we go log base b of the numerator minus log base b of the yz. See, so I'm subtracting whatever I do over here, and this is what I do in the brackets. So probably the back of the book's answer is going to be, let's see, log base b of x. They'll distribute the negative. Oh, I made a mistake. All right, this one, there's a lot going on this one. I'm going to choose to change the square root right here into the 1/2 power that we talked about earlier. So that's my first step right now. So this is log. Okay, now I see a quotient. Maybe there's a theme here. Do quotient first, quotient first, and then do the product second, and then do the power third. If I'm going to do rules, I want to check the quotient first. Don't do these in order like here. Oh, do the product first. I would do this one first. I would do this one second, and do this one last. That's what I would do, and it probably will keep you safe. So quotient first. is going on here? I got this new camera right here. Okay, I'm messing around with it because, like, where am I looking? I'm trying to. There's a camera that's in my laptop that I used to use, and it always looked like when I was looking at my looking at my laptop, I was really looking at my big screen. See, I've got a big screen right here. Yeah, I've got a great big television monitor. It helps my old eyes. I want to try to look at you all the time, but sometimes my eyes goes weird. All right, that's not working. I'll have to figure this one out. Doesn't have a very good hook. Okay. See, when I look down my laptop, I'm not looking at you. I'm looking down here. Okay. It is what it is. Okay, stop looking at me. Don't look at me. Look at this. Let's see, what do I want to do? Okay, quotient first. I'm going to go log base b numerator minus denominator. Okay, then product. And then finally, you're going to bring down the powers in front. Finally, bring down the powers in front. And I'm going to be out of room. Okay. Fine. Okay. I'll move it over here. So the 1/2 comes down in front. And you got log, the rest of it. And the 3 comes down in front. And the 4. And that'll be your answer at the end. This one here. Okay, now we'll go backwards. Single logarithm, that's what the book uses. I say squish. Push this together, squish. One logarithm. So you go backwards. If it's a sum of this, that becomes a product. If it's a difference, it becomes a quotient. If there's a number out here in front, it comes up on the argument as a power. All right, so this one here, this will be log base a of 17 times 6. And then they probably will say, hey, what's 17 times 6? You know, 1, 2, 4, 102. 102. I think it's 102. Someone can check me. I try to do mental arithmetic. Sometimes I'm not right, but most of the time I am. You know, 17 times 6, I did that in my head, no calculator. So what did I do? I went 7 times 6 is 42. I have my multiplication. And then, you know, and then I have 6 times the 1, or it's really 6 times 10. So I did 7 times 6 is 42, and I went 10 times 6 is 60. 60 and 42, I can do that in my head. And sometimes I make a mistake, but anyway, mental arithmetic in products and sometimes sums. 102. Okay. If someone checked me, that would be helpful so I don't have a incorrect answer. This one here, log base a, quotient. 17 divided by 6, leave it as 17 divided by 6. You don't need it right as a decimal like 2.9. You know, 6 doesn't go into 17, but it went into 18. It's a little short of 3. A little short of 3. So like 2.9. You don't need that. You don't need to rewrite that. So leave it like this. Probably that one, and then this one here for sure. This one, you've got a couple things going on. Work backwards. Okay, so what does work backwards? If I need to squish, this would be 1. And that's still 2, and that one's 3. If I were going to do a squish and do it backwards. So reorder these in opposite direction. So what's first? Squish be power first. So I'm going to put this up as a log base a of, okay, y to the 8th, still plus log base a of z to the 3rd. And then now finally, just push that together.
Jeff, I had a quick question for number 8.
Please. Yes.
If it turned out to be 18 over 6, would it be better to write 18 over 6 or 3?
Yes, 3.
Okay, thank you.
3, yeah. Whenever you can simplify it nicely, then that's what they want you to do. Okay, remember, this is all your test. Like, that's the biggie. Multiple choice, you want to pick the right answer. So probably, Zach, it'll have a 3. If it was an 18 over 6, the answer probably would be 3. If it's not, it'd have to say 18 over 6. So just pick the right answer on the multiple choice. Oh, and this one here, so log. Okay, there's a few things. Okay, so power first. Going backwards, I'm going to do power first. Power first still. This one is interesting. You'll see at the end what happens, but this one's interesting. Matter of fact, right now, if you knew what log base 3 of 3 is, because these are powers, then you could simplify this to 1, and then eventually be 2 times 1 is 2. But I can still keep going like this for a moment, like that. Okay, then what, Jeff? Okay. Product second, quotient last. Product second, quotient last. Remember, I'm reversing the ordering. Here, I'll do it in red. This one's first. This is still second, and this one is 3. If it's a squish, S-Q-U-I-S-H. If it's a squish, this one here would be expand. The book's word wouldn't be squish. The book's word would be a single logarithm. Single logarithm instead of squish. Single logarithm. Right as it'll look like this to start off with, and then it'll say go that direction. Okay, so I do the product next. That means log base 3. Okay, here, okay, this very incorrect. I want to make sure you understand, because I've had this happen, and it'll probably be one of those multiple choice answers that are not right. A student or two sometimes will say, well, I'm going to put below this log base 3 of 3 squared. Here, I'll show you. This is not right. Right here. This is what I'm going to write right now is not right, but students will do this because they see this as a quotient, you know, product quotient. They'll do log base 3 of y to the 8th, z to the 4th, all over log base 3 of 3 squared. That's not right. That's not a single logarithm. This is not right. So I'm taking it in steps so you can see what the right answer is. Still minus log base 3 of, excuse me. I'll still hang out for a moment there. Now, what is correct is if I went log squish again, base 3 parentheses, see, 1 logarithm. This piece is down below the 3 squared is down below. See, 1 logarithm, and then you got still y to the 8th z to the fourth. And then finally, if you want to make this into a 9, right here, that part is a 9. Probably the back of the book's answer. Probably. Okay, here comes the change of base. So who was it that didn't have, who was it that has an 83? I think there was one person. Speak up so I can see on my screen.
It was me.
Sergio, okay. So Sergio, here's your change of base. So the rest of you, you don't need this. So you can take a 2-minute snoozer break, ignore me, which you probably, most of you are already ignoring me. So how does that work? Okay, so if I went and did, let's do an example like this. Sergio, if I did log base, let's do base 2 of 8. Now I'm going to do it in my calculator and then I'll show you how to do yours. I'll do it in mine. Should be, the answer to that should be 3. Oh, math. Okay, now how you would get 3 is you would rewrite this and you'd say, and you get to pick any, this says you get to pick any base that you want. Well, why not pick base 10? You got a button here, Sergio, everybody does. Why not pick that? That's the easiest one. Well, either that or this, but I'll just pick that one. So you don't even have to write the base 10 on there. You can just go log. Now you do, this is the numerator. This is what you'll have to remember. So this goes in the numerator, the argument. My argument's 8. And the base is going to go in the denominator. Remember, this is a base 10. Put that in red. Okay, base 10. It's not a base 8. It's a base 10. So log base 10. But your calculator doesn't show that. This would be 2. So you would say log of 8 divided by log of 2. And if you did it this way, I can even do this one too. Let's see. So you would go log 8 parentheses and then go divide log 2. So Sergio, there's your workaround. Make sense?
Yeah, thank you. I got it.
Yeah, so if you were going to graph one like a while back in chapter 3.2, if you're going to graph that, you graph it like this, Sergio, and then you'll get the picture that we got earlier.
Yeah.
Okay, good.
All
See,
right, thank
so that took about 2 minutes. Now you guys, the rest of you can reawake. Let's see what else I got. Hey, I've done this one before. Haven't I addressed E before? You think, guys? Oh, all right. I guess I'll have to find out for myself. Did I do E? I think I did. Oh yeah, see, I did an E. I did E's. I talked about them. There, it's called the natural logarithm. The natural. So the natural number is the logarithm. So it's more the same right here. You know how to graph that and find the domain and range. Let's see. Yeah, you can graph those. You know, we probably already did some of those earlier in 3.2, so I'm not going to do those today. Okay, but I will do this because the rules remain the same. The rules remain the same for natural logarithms as they do for any logarithm. The product rule, the quotient rule, and the power rule. So if I were going to do this one just to demonstrate the rule, I can bring the 2 down below and I can go log base E of E. And this one feels like it's very special right here. And it is actually. log base E of E, log base E of E, log base E of E. I don't think that's going to give me a decimal right here. Log base, so I go math. Okay, log base E of E. Okay, where the heck's the E? Here's one place right there is an E. You can't see that. There's one place right there. The division number or sign. So I go second division. Okay, there's the E and do it again over here. Log base E of E is, oh, it's 1. So they probably want you to say times 2 times 1. Oh, the answer is 2. But I just demonstrated the, what do they call it? The power rule? The power rule. This one here, you put the 2 down here, and then you go ln, and you go E. And guess what? Guess what? That's still going to be 2 at the end. 2 times 1, 2. It turns out, and I'll highlight it for you, all of this right here is the same as all of this. See, so the argument is the same. The argument's the same. So that piece is an abbreviation. ln is an abbreviation for log base E. Log n is abbreviation of log base E. Just like common log, it's called a common log. If I went log base 10 of x is the same as log x. So this just plain old log with nothing down below is the same as log base 10, just that piece alone. Okay, this one here, do something. Well, I don't know what I'm, oh, I guess I could go backwards, like put the 2 up here. That's probably what the instructions will be. Do something. Okay, fine. I just did something. Do something. Now, this one's an expand again. This one's probably put the power, go backwards. This was an expand. Looks like you go ln x y minus ln e to the third. This is ln x plus ln y. Well, this is something special. And if you're not sure, then you can just do it in your calculator. It just feels special. You go ln right here, ln, and then e to the 3. Oh, it's 3. Okay, so this is some minus 3. Probably the best answer right there. Okay, if I graph this, which I think we've done that before, maybe even that exact problem, if I graph that, I just do the ln. Here's the weird thing. Okay, you don't, okay, so how do we speak ln? What was the word or the phrase? What kind of logarithm is ln?
Natural.
Log base E.
Yeah, doesn't that sound like NL? Natural log, NL, but they do LN, log natural. Oh, I have no idea. If it was me, I would have done NL, but it's not me. So you have to deal with, maybe it was French, log natural. So that's my word, bad explanation. I've tried to Google it before, the history. Why would someone, you type it all in, do ln for log now? Where did that come from? Never found an answer for me. So, Wikipedia probably has an opinion. Remember, Wikipedia is, what I understand, are people putting in their definition. All right, fine. I'm going to look myself right now. Fine. Maybe I didn't look carefully enough. Okay, fine. Natural NAT logarithm definition. Let's see what that is. Looking for. Oh, okay. Here's Wikipedia. Let's see what they say. Let's see. History. Let's see. Okay. Flemish mathematician, not French. Okay, fine. Reminder about that. Jesuit. Okay. Let's see. I have no idea. See, I can't find I can't find it. So there you go. Couldn't find it. Okay, so I'll put this in my calculator. Zoom standard. Okay, it looks like that. We've talked about this before. It doesn't stop right there. It turns. So and if you were going to plot some points, you just take a few dots from the table of values. Just take a few of these and then make sure you sketch it and make it look like it's supposed to. But the domain, okay, the domain, you can't use 3. See, 3 was a problem. See right there, 3 is a problem. So you can't use 3. So you'd say, okay, 3 parentheses 3, but you can go everywhere there. Range is all real numbers, all real numbers. Yeah, we've done these before. 2 days ago. Okay. Oh, and here's the squish again. Last problems here. Single logarithm squish. ln 7x product done. Quotient ln 2x plus 5 over x. Done. This one here. Okay, I see a quotient and power. I'm going to do them both at the same time, but be careful. It's one logarithm. ln, one logarithm. There's a quotient. Okay, what's in the numerator? X cubed, the first part. What's the denominator? Okay, the 1/2 and the y. Well, it's y to the 1/2, which is the same as the square root of y. Done. Okay, this one's a little weird. You cannot, it feels tempting to take the half and distribute it. It feels very tempting, and that's not true. So work inside the parentheses. Remember PEMDAS? Work inside the parentheses first. So I would do this first, which would be 1/2, and this would be ln of what, xy, and then take the power and then put it on the argument. So ln parentheses xy to the 1/2, which is known as ln square root xy. You know what? I might stand corrected, at least for this. I said you can't do this. Watch. I'll do it in red. I'm just looking at this. I'm thinking, why couldn't I go ln? That would be x to the 1/2 plus ln x, excuse me, y. y to the 1/2. Okay, squish it together. Why couldn't it be ln x to the 1/2 y to the 1/2 ln square root of x square root of y? It turns out to be the same. I don't know if that's always true. Could be interesting. I'd have to think about that. See, I thought maybe you can't do that, but I think you can now. Okay. So, but I did it this other way here. Okay. Now, today you do have a little baby quiz. Little one. It's on 3.2. 3.2. And when you're done, you're done. That's all I got for you. And if you have any questions, I'll be here hanging out. Over the weekend, then you need to make sure you're caught up the first 3 sections because we're headed towards that group quiz in your 3rd exam. Hey, we've only got 4 more weeks of instruction left. Seems weird, doesn't it? We got, let's see, I think 2 weeks before Thanksgiving. So you got next week, and the next week is Thanksgiving. So really it's only a week and a half. And there's only 2 weeks in December before final exams. Yeah, so 4 weeks, that's crazy. So anyway, I'll load the little quiz. I'm gonna find it first. Appears we're at number 8. I'll double check it before I release it to make sure it looks right. Number 8. Number 8. Yep. Okay, that looks good. Graph. Yeah. I don't think it'll take you very long. There are 5 problems. I don't think it'll take you very long. Okay, tell me if you see it. Number 8. I just published it. Let's see if I get a few.
I see it.
Good. Okay. So those of you who want to stick around and work with other people, good. Otherwise, you can do it on your own if you wanted to. Breakout rooms. Where are we? Breakout rooms. Here it is. Few people have left. They're doing it on their own. That's fine. Okay, let's see. Oop, I just lost another person. I want to make sure I get rooms that have at least, like ideally 3 people. Maybe I should do and recreate. 4. Okay, I'll try to get 4 of you in there. Okay, here we go. Weird. Huh. Even better than that. Thought I plugged that in.